We are building a monster chopper with 46-inch mud tires and one of KTM's finest engines. So far we've built a beautiful rear hub, a Megatron arm, swing arm, and now we have to do everything else.
I've had a moment of inspiration. The jack shaft could be stationary, secured at both ends, and the sprockets could both be mounted to something like this hub that would spin on the shaft. So step one, turn this down a little bit, make it cleaner, put a bolt pattern in it, and then make it so that I can bolt on a flange for the sprocket. Sadly, I've decided not to use it. With this design, it needs a mount point out here to hold the axle. Basically, since this thing's all about looks and looking awesome, this isn't the answer for that. So, I'll keep it around. You never know. Might use it in some future machine. So I'm gonna wait for the parts that I ordered for that to show up. And in the meantime, I think I'm gonna start designing the front hub region. I've been sitting in this chair doing CAD for many hours, and I've gone through a bunch of different versions of stuff. I've done some design in 3D and some in 2D. I'm not very practiced at 3D design because most of what I do is just a flat piece of metal. So here's kind of an idea of the spindle. Is this C-shaped chunk here? You can see it in 3 dimensions there, made out of 1/4-inch plate, of course. Hence all the flat planes. That's just a rough idea. This is a more fine-tuned, flattened piece of the edge, which you can see it would have to have a bend there and a bend there to contour to the other side. So that's all designed into there to some extent. So the holes here are centered on the bend, which would make it easier to bend right there. And of course, the holes are just for aesthetics and weight reduction. The steering axis has to be perfectly centered in the middle of the wheel. This piece here has to be shaped like that to, imagine this is the front. So that piece has to come up here and it has to wrap out and around the brake rotor because the center line of the wheel is 18 millimeters on the other side of that brake rotor, just because of the offset of the wheels. And then at that point is where this comes in, and this is gonna be the swing arm, and it goes up and over everything and bolts to the top of that C-shaped spindle thingy. Well, that looks appropriately beefy.
That's pretty satisfying.
Indeed.
It's nice and warm. It's kind of chilly this morning.
Burn off, burn off. That, in theory, yeah, I might have made the clearances a little too tight. So, if this was on top of that, which it should be, about there, it's actually quite a bit, yeah, that's actually There's not a lot of clearance for the bolt that goes through it, but that's okay. I can shave that down. And steering wise, that's actually not a problem at all. That's a decent bit of angle right there, and that's without this bending down at all. Long last, I have 2 pieces to cut. I think they're gonna work. Oh man, this is the most amount of design hours I've ever put into one part before, that's for sure. I sure hope so. I just spent a day and a half designing it. And I still have more pieces of this to design, but the rest are much easier. Oh, we have a Wookiee in the house. Did you say, oh? Yeah. I think that'll look pretty cool. Obviously this gets bends in it and whatnot, but yeah. Now fit over. You can see this little ridge here is what I had to make that little bevel for. Oh yeah, that's better. It's all the way down on there, nice and snug. That's what you want, nice and snug. Fine-tuning. The shop that I grew up hanging out in, the drawer that held the hammers was called Tune-Up and Tubing.
Okay.
It was because it was a previously labeled toolbox that it had just totally rearranged. It was already had labels on it, and he just put his stuff in there. But consequently, we used to call hammers tuners. Oh, I am turning that into a shape that I don't want it to be because I was pulling inward. That's not what you want. That's why I just got a text from.
I don't know.
It's somebody from Donut, and they're doing a list video with the shopping about the shopping cart.
Oh, that is so sick! No way!
They want to know what top speed it was got up to, but we didn't actually record it.
Yeah.
So I mean, probably like 65, but
Yeah.
we didn't.
Go so much faster. It could go so fast. Yeah, that is a premium. Nice.
is the top side gusset for here.
Oh, that looks awesome.
It's super overkill, but it looks super cool, which is the main point. That's where the Heim joint bolts in for the steering. If I get this all, you know, lined up properly. Been welding away over here, sitting next to the wood stove. We got this pretty well welded up. The one thing I messed up is that I put these plates on before I welded these hexagons, because I left these hexagons here intentionally so that I could weld these two layers together. So welding the inside edges of those has been tricky, but I've got them mostly welded. The hub setup is pretty much done. I originally designed it with the brakes being at the front and the steering arm being at the back. I think I might switch that, as I have done here, which is as easy as going whee like that. On a car, this angle here is called caster. On a bike, it's called rake. A typical angle for a bike is somewhere between like 20 and 30 degrees of rake. That's all to induce stability and make the bike want to go straight forward. But if I were to put this at, say, let's go over here to, whoa, that's about 30 degrees, then we would have way too much of a thing called trail, which is the difference between this line, this steering pivot line, you can see right here, it hits the ground somewhere over there, that imaginary line. And then the center line of the wheel, the actual contact patch with the ground, is right here. And you can see that's a big difference, like 10, 12 inches. Low speed, it would make it very hard to turn, because every time you tried to steer just a little bit, it kind of want to go flop, and kind of the steering would just flop all the way to the side. So I think what I'm probably going to do is find some sort of compromise in between that's like somewhere in between those numbers and hope for the best. We're in entirely uncharted waters here when it comes to building a motorcycle. It's not like any normal motorcycle at all. So all of this stuff is just kind of, you know, figure it out as best I can, and then just kind of pick a direction and go for it and see what happens. It's time to get a front brake rotor on this thing. I failed on one aspect of my math of this, and the size of the rear one would run into there. But conveniently, this video is sponsored by Xometry, so I'm gonna have them cut it out with a laser out of stainless steel, because it'll be stronger, it'll be much cleaner, and it won't be warped like the one that I cut out in the rear, and just more precise, because it'll be cut with a laser. I'm gonna export this, and then we'll show the process on Xometry's website. It's super duper easy. Here's Xometry's site. You just start new instant quote, sheet cutting, water jet / laser, and then material. I have just about every tier. Oh, look, we can make carbon fiber. Woo! Carbon brakes? Sure! But that is really cool. You can get your parts anodized. You can get them heat treated. I mean, we have a plasma cutter, but in this case, the part that we're making needs to be more precise than a plasma can do, and we'll get the parts very quickly. Somehow, I messed up the math when I was designing this part, and these holes for the brake calipers do not work. The end of the caliper there runs into this part of the hub. Ah! Wow, wasn't expecting this already. This is the new brake rotors from Xometry, which is perfect because I have it all disassembled right now, so I can put in the new brake rotors on the front and the rear. We ordered this 2 days ago, I think. They cut the parts and shipped them here in like 2 days. Ridiculous. Oh, wow, that is perfection.
Nice.
My new design is so much better too. It's still got kind of hexagons, but they're elongated with little roundy bits. They just look... That is some sexy brake rotors right there. Services. Then I got the front one on there. That looks very nice. It's got wings. Why does every one of these things look like some sort of weird animal? Like if you turn this up this way, now it looks like a deranged goat.
It does.
If you don't think about like these parts, just that plate.
It's like a cyclops goat.
Yeah. I'm gonna make steel sleeves that weld onto here to fill up the gap anyway, so the fact that I had to widen out those holes a little bit is not that big a deal. I am super stoked with how this front part came out, and I love these new stainless rotors from Xometry. So head over to xometry.com/grindhard and use code GRINDHARDER50 to get $50 off your order of $250 or more. Or click the link in the description, that'll get you there too. Finally got all the parts for the jack shaft. Got my sprockets here with hexagons. I actually have a couple different sizes here for gearing options. And then I have these bearings that also fit the old hexagon. Well, look at that. Hexagon bearing. Oh, nothing like a fresh pair of safety glasses. Googly eye down. I realized as I was making that cut that was going to be a problem. It needs to be from there up. Look at that. Turned out rather nice for a crusty old piece of pipe. So this is just one side. You can see the other side's not done yet. That's where it was in the jaws. I was gonna go do the other side, but then I realized it'll make my life easier if I just press this bearing in now. Then I can measure to it to figure out how deep to set the other one. Just like... thinking that I'd need to put like snap ring grooves to keep the bearings from coming out, because like as I talked about, I'm going to put bolts in the end of this to hold this all together, but I was thinking, oh, well, that doesn't necessarily hold the bearings in this sleeve, but because of the little machine ridge there, it does. Because if they're held in from both sides, then this one can't go that way and this one can't go that way, so the only way they could go is out. Well, and if they're sandwiched from the outside with these, they can't go in any direction. As previously measured, the goal for the diameter was exactly 3.14. Gotta love it when your numbers are exactly pi. I'm gonna make the spacer that goes in between. This is 1 3/4, and it's a little wobbly, which is annoying. 1.5 inches is not big enough at all. The closest I found is this piece of aluminum pipe, and it's almost big enough, so I just have to bore the inside out a little bit. And it doesn't, I mean, this is satisfying too, because 1, it won't rust, and 2, it's weight reduction! Good, yes, helpful, thank you. On today's episode of unnecessarily complex parts, I mean, it's not complex, it's just unnecessarily perfect. It has 0 slop. Fits that perfectly. So that goes there, this goes there, that goes there, and then of course this houses the bearings. So this one roughly lines up with the outside edge of that tube there behind it, and this one lines up, of course, with the sprocket, which just means the engine isn't in the right place because it's just kind of chilling there. Like nothing. I may need an OCD intervention here pretty soon. I was just polishing my washer because it was crusty. Look at that. We got threads for 10mm bolt, and you can see they're even recessed so that if this shoulder goes in there a little bit, there's a recess for that. And then I chamfered the edges on both ends. Sure. This shaft is made out of cold rolled steel, but it's not hardened. Because of that, being cold rolled, it's just very nice consistency. It's like butter that's just the right temperature to spread on your bread, you know? That's satisfying. Anyway, machining it is like that. So I do still have to weld these together. I think I have to put it back in the lathe and take just a smidgen off of it. Got my chain looped around here in such a way that I can do a test fit here of this and determine 1, how long to make the chain, and 2, in relation to that, how far away this should be from this. Obviously I'm going to need tensioners on here. I thought about making this movable as a tensioner, but 1, that's super complicated, and 2, it wouldn't be particularly helpful because if you're tightening this chain, you're loosening this one and vice versa. So they're both just gonna have to have roller tensioners, which aren't the best. It'll have to work in this case. The dogs like the new shop. They can hang out in here with us without feeling trapped. When there's loud noises, they can go all the way over there and be far away from the scary loud noises. That'll be the pivot bolt, but then we need a bushing. And I went over there to that wall of pistons, and I found some wrist pins out of a set of those pistons. I think they're actually the old pistons out of the Barbie camper. Anyway, they fit perfectly on the 14mm bolt, which is extremely convenient, and they're very polished, so they'd make an excellent sleeve, and then the bushing would go around it. They also just happen to be within about, I don't know, 3/1000ths of an inch of the same length as this. So this is the swing arm pivot, and then this part goes to that. So that'll tie it to the swing arm pivot, and then of course on the other end it'll go to the chassis and whatever will be welded to this. If I'd been really thinking, I would have welded this on there before I put the bearings in. But if I cook them, I'll have 2 more. Well, got that all welded. I think the bearings are only medium rare, so that's fine. Medium rare bearings are good. They actually roll a lot easier now than they did before I welded it, so that's perfect. Less rolling resistance. It goes like that. But there's a little bit of empty space in there, so before I can assemble this, I need some plastic bushings. I just have one little snippet there to weld, and then these can just go in permanently. Okay. What we have here is a chain tensioning device. Of course, it won't work that way once it's, installed. I mean, it will to an extent, because of course, when the swing arm pivot is not concentric to the sprocket shaft, then suspension travel changes the tension of the chain. I've also cut out these 2 little wedding rings here. So I have this is the old swing arm bolt, which obviously I'm going to use as a mount point for the chassis because it's a very sturdy place to mount things. And the way that I'm going to mount it is a piece of tube, coming something like that. But I want a piece of 1.5" tubing here for things to weld to. So these, they need a little bit of a smidgen of die grinding, but those fit over this, and I'll weld them on each end of a little short section of tubing so that can be clamped in right there. Now comes the fun part. Well, actually, this whole build has been super fun. Now I get to design the chassis. You can see I have a few tubes sort of propped up there to visualize things. It looks a lot better in my head, but you get the idea. I'm making use of our flat floor and rolly chair to gain perspective. Man, it's so nice being able to sit back and look at something from a distance. It's the stage where I stare at things and rearrange bits of metal for hours before actually doing anything. They're symmetrical, equal, made out of the same material, and they look the same as the other side. I realized I should do the smart thing here and weld this up before I put the bushings in, because nothing else gets attached to this. His favorite game now is put the ball under the mill and then yell at us to get it out. Hush. Now that I have all that done, I have this made, which is a piece of 1/4 inch welded onto the end of 1 3/4 tubing with a hole for this. So that goes there. Time to finally unite the swing arm with the engine. Well, my estimation of how much I needed in the middle was a bit high. I'm gonna try out one of these new hole saws that RoadFab sent us. This one specifically is fine tooth, and I'm gonna try it. I have a feeling it's gonna be better than the coarse. I don't know. Seems to be maybe a cleaner cut. Less chattery, that's for sure. Yeah, that's getting pretty close. Well, I got this piece all pretty much perfect here, but I don't think I like it. When there was nothing attached to it, I liked this piece here. But looking at it now, I think I could make it slimmer and sleeker. Freaky with the lathe the other night and made this extremely precise and satisfying spacer sleeve combo here. I made this thing to attach stuff to, you know, here, and then I decided I needed it to be longer, and while I was at it, I decided it needed to be about 1,000 times nicer. So I made this. Took a piece of like almost 2-inch solid stock and bored it out to an extremely satisfyingly precise fit. And then the end of the bolt slides inside the end there. And then this, I just finished on the lathe just now, is a little Delrin bushing that just goes right there, which is snug, but it can still spin. So that when the chain slaps around, it hits plastic that can spin instead of metal.
That's really cool.
It's extremely overkill, but so is this whole procedure. So I also have this piece here kind of mocked up. I finished putting a threaded insert in the end and then put a bolt through there from the other side. So that's getting pretty close. I have to make sure everything's all aligned right before I tack that. But yeah, pretty soon the engine will actually be attached to the swing arm. I had the idea to design some tabs that are kind of similar to these ones, and then put this little section of tube here in between them, and then run my other tubes to that. And it'll kind of match the look of this, like asymmetrically similar, we'll call it. It's not symmetrical, obviously. This is a giant hunk of tube. This is a small one, but I think it looks a whole lot cleaner than that piece sticking out here. And it's more in line with where they need to go, because the tube needs to go to here and then one down to that side. So like it makes more sense and it's stronger. Last night I got this bit over here connected. I'm pretty happy with how that came out. I'm not gonna make this tube until I have the exhaust because I don't want it to run into the exhaust, obviously. So it probably will clear just going straight, but I'm not gonna waste the time making it if it's not gonna work. So while I contemplate the next step, I'm gonna put an actual chain on here and cut it to length. Look at this, it's a rare occasion. We actually have a functioning chain brake tool and I'm using it. Both chains are nice and tight without any chain tensioners, which of course they will loosen up and then I'll need tensioners, but at least for the first test drive, whenever that may be, I don't have to worry about it. Good notch. Except that I can't get it at the right angle because it runs into the tire right there, but that's okay. Anyway, you get the idea. This is gonna be the part that the seat goes on. It just needs a little bit of clearance here because of how long the tire or swing arm is. Even if this part only travels 2 inches or whatever, that end is gonna travel 6 or 8 inches. It's about 13 inches or so from the center of the pivot to like that weld there. So if you draw a line with that here, or a radius rather, tape measure, you know, say come out to there, right? That's where that point would hit it, if it's traveling on that radius. Well, that is like 3 inches of travel on this radius. Well, this radius is 13 inches, and this radius is 32 inches. Anyway, it's gonna kind of, you know, come back, have a little spot here where I can build a seat later, and then come to some sort of point or rounded point or whatever. I got that one roughly made, but to figure out exactly how I want to merge them, I need to make the other one. Got my first bend here, and little tip, if you have multiple clamp blocks for your tubing bender, and you want them all to be in the right plane, you can just put them like on a bend like this. You can put one on either end just loosely, and it'll sit flat then when it goes through all 3, as long as you're on a flat surface. Just slip these off, and then you're definitely at exactly 90 degrees or exactly parallel to your previous bend. And just like that, there were 2. I've realized that it's asymmetrical. You can see here where this tube's gonna connect is, you know, that whatever that distance is, I don't remember, 1 3/4 or something out from the case. This side is right up against the case. You know, that's fine aesthetically and all that, but the seat needs to actually be in the center of the bike, and the seat's gonna sit on this. I think I can just kind of play with the angles a little bit and finagle it and make it look symmetrical. Handlebars.
That's very nice.
Yeah, much higher seating position than I had originally intended, but still plenty low to the ground, you know, to reach, you know, comfortably. mind me, I'm just out here harvesting shocks. They grow.
Are they actually ready to be picked though?
They are. These ones are very ripe. See that one there? It's already on the ground. That's how you know it's ripe.
Ah, yes.
They literally grow on trees here. I'm not sure which of these shocks I'm gonna use for this, but I'm just gonna grab all the ones we have out here, which is an alarming amount actually, and I'll just kind of, you know, see which one's the best length and whatnot. At the moment I'm grabbing them all off these street bike chassis. Because of the geometry and length of my swing arm, I need a shock with very small amounts of travel, or else I'll just end up with too much wheel travel on the bike, and it'd be too tall or too soft or whatever. I'm just harvesting street bike shocks because they're much shorter than dirt bike shocks or, you know, ATV shocks or whatever. So yeah, I'm harvesting the linkages as well because you never know, I might come up with some silly design that needs a linkage. This is the totaled CBR 1000 that Will got for the Ruckus project. So CBR 1000, Ninja 600, and Hayabusa. So, you know, all sorts of different things out here. Oh, that's a good harvest. Good crop. Look at all those shocks. The one that I looked at first and thought I would want to use because it's the shortest, just for packaging reasons, has an annoyingly positioned reservoir. Like, I want it to go something like that, and that just kind of is in the way. Like, I'd like it to either be totally horizontal or follow the angle of this bar. That one's a good bit longer. That's the Hayabusa shock. It's also off the heaviest bike, so you know, that would be relevant, except that the middle portion of this bike isn't going to be that heavy, or rather, the sprung portion of it that the suspension is, you know, working on isn't that heavy. This is just really basic sketches representing like tire size, swing arm length, and then this circle here represents the distance from the pivot point to the shock. So as the swing arm goes up and down, that line is doing this. To figure out how much travel I'm gonna get, what I do is just figure out the, you know, the travel that the shock has, which is, it's really only 1.5 inches. But let's say you really slam it into the little rubber bumper and it's 2 inches. Yeah, it should work out pretty well too, because these shocks are made for a street bike, which you want to be pretty stiff, right? Not a lot of travel, pretty stiff suspension. And with this, I mean, it'll be ridden on the street, but it's also intended to be ridden off-road. So we want something in between, and taking the shock and getting more wheel travel out of it means we're making it softer. What we have here is a CBR 900 RR, which is what the shock came out of. And it has 4.7 inches of travel in the front and rear. So if we go more than that, we get softer, which is probably good. Those will work perfect. I have to finish welding this tube on, otherwise I won't be able to. And then I'll have to grind a little bit so that these clear the welds, because you can see it doesn't quite fit tight, but that's gonna look and work perfectly. Man, I didn't think I was gonna get the rear suspension attached today, but apparently I am. And as we go travel down, we're looking at about, you know, 1.5-inch-ish of travel this way for the travel that we have down. Oh, wow. This whole system has been awesome. It's awesome because in like days of using the lathe, that's all the fluid I've used. It just uses compressed air and creates like a little mist of lubricant / coolant, and the air is what cools it. And then of course there's a smidgen of lubricant in there, and it just helps a lot. Our last Harbor Freight order got some of these transfer punches, which is super handy for this because, check it out. Put that through there, and then, you know, give it a little whack. Now we got a nice little punch mark there for drilling a hole. I'm really happy with the design. It came out a lot better than the first iteration. Not that there was anything wrong with the first iteration, but if you're gonna do it again, you might as well make it sexier. Got the rear reassembled, and you know, that's all put back together. So now I'm gonna carry on with my caliper mount relocation services. With all my TIG welding of fancy plasma cut parts lately, I've been thinking about better ways to remove mill scale so that you get a cleaner weld. And I was browsing around on the interwebs, and I found these, which are for stripping paint and stuff, but it just eats the mill scale. Somehow, after all of that, I still managed to get these holes off, but this time only by like a teeny tiny bit. This piece by itself looks super duper cool, but when I put it on there, I still didn't like it, and the way I'd put the brake calipers like basically touching, I mean, it kind of looked a little silly, and also, not that I think it would have ever been an issue, but from a design standpoint, like all the forces on one side instead of spread out, and like there's not as much time for the rotor to cool between the two brakes. Not that any of that matters in this case, but I decided to just go ahead and fiddle around with it and see if I could come up with something that was like conceptually better and that I liked better. And I came up with this. So this is ideal for multiple reasons. The main one is that it puts the calipers like almost exactly, well, actually perfectly opposite each other on the rotor. And it puts them so that both bleed screws face up, so I can bleed both the brakes in place, because I figured, yeah, it doesn't really matter. You could take it off and bench bleed it and then put it back on, but if I'm gonna redesign it for the third time, so the fourth iteration, I might as well make it the best it can be. So this is what I came up with, and I kind of integrated the mount for the steering into both sides to make it nice and symmetrical, but then I made it asymmetrical because this side needs to have little braces welded to it for the steering ram to actually attach to. This side doesn't, so they're symmetrical but asymmetrical just slightly with the hexagons and circles and. sometimes fourth time try. What does this one look like in that direction? I'm not sure, but it looks way better than any other iteration. I don't know if I'm just having a good day. I could maybe give Everlast some credit for this nice welder, but that's the best weld I've ever done.
That looks nice.
Yeah. There's always room for improvement, but that's the best I've done so far. Very nice. I'm finally actually really happy with the way that looks. Now I need some spacers for the brake calipers, and I want them to be steel so that they can be welded on here and make it super extra strong. He's got suspension. I'm gonna have Edwin pull me across the shop in this so that I can imagine that I'm driving it.
Can I just pull you from here?
Yeah, that's the plan.
All right, you're ready?
I'm ready.
It's first drive.
This is a new first test drive method. I definitely have to lean right. It's all offset.
Oh, you can see the gear reduction really well.
Yeah, you can see the. Oh, that's first gear. Hey, I have brakes.
You almost bump started it.
Yeah, right. You can really see the gear reduction there. How fast this is turning versus that. That's cool.
That's super.
Man, just seeing that big, giant tire move, this is gonna look so cool when it's done.
Oh yeah. You can tell it's a little not balanced weight-wise. It really wants to be leaning.
It's like, this size tire is bigger than like 90% of the real mudding trucks. Like,
Yeah, I mean, like, a lot of people don't really use, 46s are definitely bigger than anyone, like, mud trucks, yeah, people use bigger tires, but like, all the other types of off-roading, like rock bouncers and like, all of that, they don't use 46s. Now that I've got rear suspension, sort of a seat, and the front hub, I think the next step in the next video is gonna be building a little bit more of a chassis up here and figuring out where my pivots are gonna be, and then building the front swing arm, because it's gonna be a single-sided swing arm, not forks.